Okay, so now let us try to go through these questions. Let us start with question number 8, Euclidean Geometry. Now, 8.1, it reads as follows. It says to us, in the diagram below, BD is parallel to EF. We can see that BD here, it is parallel to EF. We need to confirm also on the diagram that is true. And again, AB is parallel to DE. AB, which is this line, is parallel to DE, which is this line. And therefore, we are also told that BE is equals to EC. Where is BE? BE is equals to EC. Both of them, they're equals to 6 centimeters. And the AD, which is from here to here, is equals to 10 centimeters. So everything that we are told, it is also indicated on the diagram. So it's very important for you to read the statement and confirm with the diagram, because sometimes they can say AD is equals to 10 centimeters and it is not even written over there. So you're going to have to write it with your pencil so that you do not get lost during the calculations. That is a strategy that I can share with you. So now for 2 marks, which is 8.1.1, it says to us, show that FC is equals to 5 centimeters. So we want to show that from here to here, we actually have 5 centimeters for only 2 marks. That means this question, it is easy. So how are we going to show that? Now, what is given? We are given BE, we are also given EC. Now, when you have a look at this diagram, you can see that you have many parallel lines. So when you have parallel lines, grade 10s, think of the basics. For an example, think of midpoint theorem. We know that when you have the parallel lines and when you have equal sides, you can think of a midpoint theorem, nothing else. So in this case, we want to determine FC, but I see that if we talk about triangle BDC, that's where FC I can see where it is located onto. So I can use BE and EC, and then we'll also use these parallel lines, which is EF and BE, to talk about the midpoint theorem. But the problem is I do not have DF. If I had DF, for an example, DF is 7. That means FC will also be 7. But at this point in time, I don't have DF. I don't have DF. But do I have DC? Also, I do not have DC because I know that, check, if this is a midpoint theorem, I know that DF will be equals to FC, right? If I had the total side of DC, I was gonna take half of this side, and let's say maybe here it is 10. I'm gonna say 10 divided by 2 is gonna be 5. So that means DF is gonna be 5, FC is gonna be 5. So that means I need DC or I need DF. But apparently the only thing that I can calculate here, it is DC. Question is again, how am I going to calculate DC? I'm going to use the big triangle now. Which triangle to determine DC? Let's have a look at that triangle. Triangle ABC can actually help me to calculate BC. How? I can talk about midpoint again. I can see I have parallel lines, which is DE and the AB, right? And therefore this DE, the very same parallel line, it cuts BC into 2 equal parts. It cuts into BE and EC, and they're both equals to 6. So again, I can talk about midpoint theorem. Now I have AD, which is 10. So that means for a fact that this is a midpoint theorem, AD will be equals to DC. That means DC will also be equals to 10. Now I have my DC. I can go back to that triangle again that I started with to use midpoint theorem to determine FC. But you need to write everything down. This is only for 2 marks. So to determine DC, how did we determine DC? We just said DC is equals to 10 centimeters. Why do we say DC is equals to 10 centimeters? Because we can simply see that we have this line, okay? This line, it cuts the midpoint. Bon, BC, point E, it is the midpoint of BC, because we can see that DE, it bisects DC into 6 and 6. So that means this line, which passes through the midpoint, it is parallel to the third side of a triangle, which is AB. So that means you're going to say line through midpoint, right? It is parallel to the third side, some they say second side, to the third side of a of triangle. You can just say of triangle, right? Of triangle what? Of triangle A, B, C. That's what is happening. You do not just write that this is 10 centimeters. You write why. What's the reason? Why do you say this is 10 centimeters? Because line through the midpoint, which is this line, it is parallel to the third side of this triangle, of the third side of this triangle, which is called triangle ABC. Therefore, we can simply say that this is 10 centimeters. Now, we are not looking for DC, we are looking for FC. So how to determine FC? Now we know this side. Again, we said that when we have a look at triangle BDC, we can see that again, E is a midpoint of the very same side, which is BC, whereby this is 6 and 6. Now we have the parallel line that cuts the midpoint of BC. This parallel line, this EF, this parallel line, it is parallel to the third side of a triangle, but which triangle? DBE. Now DBC. Now we can say that DF will be equals to FC. But for the fact that we have 10, we're going to divide this 10 by 2. Therefore, here will be 5, and therefore there will be 5. Now we can simply say that FC will also be equals to 5 centimeters. How do we know that FC is 5 centimeters? We're going to use the very same reason, but instead of you saying triangle ABC, now you're going to say triangle BDC, meaning you're going to say this line, which is a line through the midpoint, acts parallel to the third side of triangle BDC. For 2 marks, you collected. You are good. I hope that was clear. I hope that was clear. Right. Now, we move to the second question. Now, the second question says to us, if AB is equals to FC, prove that A angle BC is equals to 90 degrees. They say if AB is equals to this, we want to prove that ABC is 90 degrees. Let's go back to our diagram. Let's go to check where is ABC. Now, let me erase everything. Now, we want to prove that this is 90 degrees, okay? A angle BC. We want to prove that this angle, it is 90 degrees. A angle BC. We want to prove that this is 90 degrees, right? So they told us that AB, right? They say that AB is equals to 16 over 5 FC. 16 over 5 multiplied by FC. We are told that this side is equals to this. So what is the magnitude of AB? That's the first thing that we're gonna do. So let's go answer that side. So to answer question number 8.1.2, you're gonna say, okay, we're going to determine the magnitude of AB using this equation that is provided. So here we have 16 over 5, but we have already determined that FC is equals to 5 centimeters. And therefore, when I punch this, 5 will cancel 5. That means I will left with 16 centimeters. So that means side AB, which is this side over here, will be equals to 16 centimeters. Now, what will be side BC? Side BC in this case will be equals to 12 centimeters, which is provided. We can see that it's 6 plus 6 is going to be 12 centimeters. So the question wanted us to prove that this angle is 90 degrees. So now how are we going to prove that? Remember, we said that, do not forget, we said that BC, it is also 10 centimeters. So we're gonna calculate, ne? Remember, Pythagoras theorem, it states that this will be, if this is 90 degrees, right? If this is 90 degrees, AC supposed to be a hypotenuse. So what we're gonna do is, we know that hypotenuse, it is the sum of these two sides. It is the sum of AB and BC. That's hypotenuse. That's what we know, right? So what I'm gonna do is, I'm gonna determine the sum of AB and BC to see how much I get. You understand what I'm saying? I'm going to calculate the sum of AB and BC to see how much we get. So how are you going to determine this sum? Okay, we're going to use Pythagoras, just like Pythagoras, right? So that means we're going to say AB squared plus, it's AB plus BC, plus BC squared will be equals to how much? It's supposed to be equals to AC, right? It's supposed to be equals to AC squared. Now, if this is true, therefore, that angle, which is ABC, will be 90 degrees. So let us determine this sum first, which is AB squared, to determine AC. So AB in this case is how much? AB is 16. Remember that AB here, this, we have 16 to the power of 2. BC, we said it is 12. So here it's going to be 12 to the power of 2, which is equals to AC squared. So now what is 16 to the power of 2? I think it's 161. 16 multiplied by 16. Oh, it's 256. 256 plus, you can just, okay, it's fine. We have 256 plus the 12 to the power of 2 is how much? 12 to the power of 2 is going to be 144. Which is equals to AC squared. And therefore, let's add them together. We get 400. So that means here we get 400, which is AC squared. Now, let us determine AC. We're going to take root side on both sides. Therefore, our AC, what is the root of 400? It will be 20. So that means in this case, based on this calculation, we get that our AC in this case, which supposed to be hypotenuse, it is 20. So when you go back to our diagram, let us check that if we add these values on the diagram, are we going to get 20? Yes, we are getting 20 because we know that to get AC, we're going to have to add AD and DC. AD and DC both are 10. When you add them, they give you 20. So that means it is true that AC, it is hypotenuse. So that means this angle, that means it is 90 degrees, because we know that if we have something like this, if we prove something like this, if this is true, that means the angle subtending hypotenuse, it is 90 degrees. So this is the converse of Pythagoras theorem. We know that Pythagoras theorem is something that looks like this, right? Pythagoras theorem. If they tell you that this is 90 degrees, if they tell you that this is 90 degrees, what does this side mean? That means this side, it is hypotenuse. If they tell you that this side, let's say this is let's say this is A, B, C, A, B, C. If they tell you, check, Mona, they tell you that we have 90 degrees. Here they tell you that we have 90 degrees. So what you need to prove is AC, it is hypotenuse. You need to prove this. Here, they tell you that AC squared is equals to AB squared plus BC squared. If they tell you this, that means here, you need to prove that here, you need to prove that angle B, it's 90 degrees. So here, it is hypotenuse, it is the Pythagoras theorem, and then here, it is the converse of Pythagoras theorem. Pythagoras theorem, they always tell us here it's 90 degrees. If they did not tell you we have 90 degrees and when you have to prove, that means you are using the converse of Pythagoras theorem. So in this case, we determine that AC is 20 degrees. That means A angle BC will be equals to 90 degrees. What is the reason? Why do we say that? We use the converse of Pythagoras, uh, Pythagoras theorem. This is what we did. We used the converse of Pythagoras theorem by determining that AC, it is indeed proving this, which is hypotenuse. So if AC is hypotenuse, we can simply say that we are now safe to say this angle is 90 degrees. This is what we actually did over there. I hope that was clear. I hope that was clear. Right, so now we jump to question number 8.2. Now 8.2, it says to us for 5 marks. In quadrilateral, A, B, C, D, you are not told. There's just say it is quadrilateral. Okay, A, B, C, D. Sorry, A, B, C, D. AD, where is AD? AD, it is parallel to BC, and angle B, which is this angle, is equals to angle D. You see, it is not indicated on the diagram. To make life easier, indicate it so that when you do your whatever, you don't get confused. So that means they say to us, this angle over here will be the same as this angle over there. It is given. Prove that this quadrilateral, it is actually parallelogram. When you prove your quadrilateral, which is four-sided figure, quad means four, lateral means sides. So we have four-sided figure. We can be square, it can be kite, it can be rhombus, it can be. Familiarize yourself with the properties. We know that to prove that a quadrilateral, it is a parallelogram, we need to prove that only two sides. You don't have to prove everything. Just prove that two sides are parallel and equal. Just prove that. I don't care whether you prove AB and DC, you are good, or you prove AB and BC, that AB and BC are equal and parallel. Well, if you prove those two things, you are good, you get your full marks. Or you can prove that AB is equals to DC and AB, it is parallel to DC. You are good, you get your complete marks. So, or you can prove that the diagonals, they intersect each other at this point. Those are the properties that you really need to familiarize yourself with when it comes to the quadrilaterals. So this is what I'm going to do. I'm going to prove that AB is equals to BC, and I'm going to prove that AD, it is parallel to BC. So we can start by proving that they are parallel, or we can start by proving, oh, already they are parallel. We don't even have to prove that. We are told that AD is parallel to BC. So what is left now for us to prove? What is left is we need to prove that they are equal. They are now equal. That's what we need to prove. But how are you going to prove that AD is equals to BC? Let me show you. We have two triangles. We can talk about the congruency. When you talk about the congruency, we are talking about the same triangles. Let me give you this basic before I can even prove this. So let's say we have two triangles over here. Ne? We have two triangles over here. I'll call this A, B, C, D, E, and F. If the triangles are congruent, what does that mean? They are exactly the same. So that means this side is the same as this side. This side, it is the same as this side. This side, it is the same as this side. These triangles, we say they are congruent. Again, congruency, we can use one angle. Maybe this angle is equals to this angle, and then these two sides are equal. That's also a congruency. Then, similarity. Triangles that are similar are not equal. They are in the same proportion. They are not equal. The only thing that is equal about triangles that are similar, they have equal angles. They have the same angles. This angle is the same as that. And this angle is the same. These angles are the same. Mara, the sides are not equal. If this is 2, this will be 4. If this will be, let's say 4, now this will be 8. If this is 8, now this will be 16. Ratio is the same, but the angles are equal. We say they are equiangular because they have equal angles. This is similarity, and this is congruency. Congruency, they are 100% the same. They are the same with the angles, they are same with the sides. That's congruency. So this is what I'm saying. Remember, we want to prove that this thing, it is a parallelogram. So already, I'm going to focus on these two opposite sides. I have already proven, or it is already been told, that they are parallel. So what is left is I need to show that these sides are also equal, and therefore I am good. I get my 5 marks. But how am I going to prove that same? I'm going to use these two triangles. I'm going to have to prove congruency. I'm going to have to prove that this triangle, it is actually the same as this triangle, so that I can say this side of this triangle, it is the same as this side of this triangle. That's the reason why I want to use congruency. Okay, so now let us start. Now let's have a look at these two triangles. So in triangle ABC and triangle ADC, what is happening in those two triangles? This is what is happening. I want to see what is the same. Aha, I can start with what? Let's see. Let us start with the what? We can start with the what? Then we can start with the angles, we can start with the sides, we can start with everything. Okay, so that means let us start with the angles. So this angle is the same as that angle. So because I mentioned the ABC this side, so I'm gonna say everything that's ABC, and this side I'm gonna say everything that says ADC. So from ABC I have angle B. So I am going to say angle B is equals to what? Angle B is equals to angle D. Is equals to angle D. But the thing is, what is the reason? Why am I saying those angles are equal? It is given. Literally from the statement, everything was actually given. It is given, right? Now, this is what is happening again. When you have a look at angle A, 2, and then angle, you see you have parallel lines. Don't forget that. When you have a look at angle A2 and then angle C1, they are equal because they are alternating angles within the parallel lines. So that means for a fact that this side is angle ABC, I'm going to say angle C1 will be the same as angle A2, will be the same as angle A2. What will be my reason? My reason is they are alternating angles. They form Z. This is alternating angles. This will be equals to that. This is an alternating angles, right? But again, you need to provide why do you say they alternate? It's because AD, it is parallel to BC. It is because AD, it is parallel to BC. Hence why I'm saying I have two angles which alternate. Now, I'm not going to use this angle and that angle and say they're the same. Therefore, I will be talking about similarity, okay? So I need side. I'm not going to say this and this, they're equal, third remaining angle of triangles. No, I'm not going to say that. I'm not proving similarity here. I'm proving congruency. So what is the same again is this side. Can you see AC for this triangle and this triangle? AC, it is the common side. So I can say AC is the same as AC, or you can just write AC, it is still fine, and say common, Now, in these two triangles, now you can say triangle A, B, C, it is actually congruent to triangle ADC. And you give the reason why do you say those two triangles are congruent? Because we use the angle, and the side. That's why we say these two are congruent. Now, remember, for a fact that this side is the same as that side, that means AD will be the same as BC. Therefore, we can say from the congruency, we can say that AD is basically equals to BC. Not only they are equal, AD, it is also parallel to BC, which was given. Why do we say they're equal? From the congruency. Why do we say they are parallel? Given. Now, this is what we only needed. Now, we can say that A, B, C, D is a parallelogram. What will be the reason? We proved that we have sides. We have opposite side, not just sides, right? Opposite side, okay? We have, you give a reason, and you're supposed to give a reason like that. You give a reason up, you're gonna say opposite sides that are equal and parallel. You close your bracket. You get your free 5 marks just like that. You only needed to prove that two sides, two pairs of sides are parallel and equal. You can also prove that this side and this side are parallel and equal. It is still fine. You can also do it in that way, but it was going to be difficult because we are not told that AB is, and you're going to need congruency and you wouldn't be able to do that. But this was the way to prove this question. This was the only way to prove this question.